Download this code from codegive.com, link in the description below. The perils of date and time, avoiding common mistakes and mastering handling in code. Date and time handling seems straightforward at first glance. You have a date, you have a time, combine them and move on, right? Unfortunately, this couldn't be further from the truth. Date and time operations are rife with pitfalls, complexities, and potential for bugs that can be incredibly difficult to track down. This tutorial will explore common mistakes in date and time handling, explain why they happen, and provide code examples in various programming languages to illustrate both the errors and the correct approaches. Why is date and time so hard? Before diving into specific mistakes, understanding the inherent challenges is crucial. Ambiguity human language surrounding dates and times is inherently ambiguous. Next Tuesday could mean the upcoming Tuesday or the Tuesday after that. Yesterday depends on the current context. Varying calendar systems the Gregorian calendar, used widely, isn't universal. Other cultures use different calendars, each with its own rules and peculiarities. Time zones the Earth is divided into time zones, each with its own offset from Coordinated Universal Time, UTC. Furthermore, time zones can have complex historical changes, including daylight saving time, DST, rules. Leap seconds to keep atomic clocks in sync with the Earth's rotation, which isn't perfectly regular, leap seconds are occasionally inserted. These are unpredictable and cause havoc in systems not designed to handle them. Representation dates and times can be represented in numerous formats, strings, integers, objects, and converting between them can lead to errors if not done carefully. Cultural differences date and time formats, such as the order of day and month, mm/dd/yyyy versus dd/mm/yyyy, vary widely across cultures. Common mistakes and solutions. Let's delve into the most common errors and their remedies. 1. Ignoring time zones. The problem storing dates and times without time zone information leads to ambiguity. A meeting scheduled for 3 p.m. is meaningless without knowing where it's 3 p.m. This can lead to scheduling conflicts, incorrect event timings, and data corruption if dates and times are used across different geographical locations. Why it happens It's easy to forget about time zones when dealing with local data or when a project is initially designed for a single location. Laziness in not wanting to deal with the perceived complexity also contributes. Example, Python, incorrect. Example, Python, correct. Key principles always store in UTC the best practice is to store all dates and times in UTC in your database or persistent storage. UTC is a universal standard and avoids the complexities of local time zones and DST. Convert to local time for display when displaying dates and times to users, convert them to the user's local time zone. This provides the most relevant and understandable information. Use time zone libraries leverage robust time zone libraries like pytz, Python, Java.time, Java, Moment Time Zone, JavaScript, Notatime, .NET. These libraries handle DST transitions, historical time zone data, and provide functions for conversion and manipulation. Be aware of IANA Time Zone Database The IANA, Internet Assigned Numbers Authority, maintains the Time Zone Database, TSTDA or Zone Info, which contains information about time zone boundaries, historical changes, and DST rules. Your time zone library should use an up-to-date version of this database. 2. Incorrect date/time formatting and parsing. The problem using incorrect format strings when converting dates and times to / from strings leads to errors. For example, using mm/dd/yyyy when the date is actually in dd/mm/yyyy format will result in incorrect date values or parsing failures. Cultural differences in date and time formats further exacerbate this problem. Why it happens. Format strings are often complex and use specific symbols for representing different parts of a date and time. Misunderstanding these symbols or being unaware of cultural differences leads to errors. Example, Java, incorrect. Output, error parsing date, text 13/01/2024 could not be parsed, parse exception at index 0, or, in some cases, it will incorrectly parse the date as January 13th. Example, Java, correct. Key principles use standardized formats, ISO 8601 whenever possible, use the ISO 8601 format, YYYYMMDDTHHMMSSZ, for storing and exchanging dates and times as strings. This format is unambiguous and widely supported. For example, 2023-10-27 T10:30:00Z, UTC time. Specify format strings explicitly. When parsing or formatting dates, always specify the format string explicitly. Avoid relying on implicit or default formats, as these can vary depending on the locale or system settings. Use locale-aware formatting. For displaying dates and times to users, use locale-aware formatting. This will ensure that the dates and times are displayed in the user's preferred format, based on their locale settings. Many libraries have methods like datetime_formatter.localizedDate, Java, or toLocaleString, JavaScript, to handle locale-specific formatting. Handle parsing errors. Always handle potential date-time parse exception, Java, value error, Python, or similar exceptions that may occur during date and time parsing. Provide informative error messages to the user. Validate inputs. Before parsing a date or time string, validate that it conforms to the expected format. This can help prevent errors and improve the robustness of your application. Regular expressions can be useful for validation. 3. Ignoring daylight saving time, DST, transitions. The problem DST transitions, when clocks are moved forward or backward, can cause significant problems if not handled correctly. During the spring forward transition, an hour is effectively skipped, so a time like 2:30 a.m. doesn't exist on that day. During the fall back transition, an hour is repeated, creating ambiguity. Why it happens. DST transitions are complex and vary by region. They can be difficult to reason about, and many developers don't fully understand the implications. Example, JavaScript, incorrect. Example, JavaScript, correct, using moment time zone. Key principles. Use time zone libraries. As mentioned before, rely on robust time zone libraries that handle DST transitions correctly. Avoid manual calculations. Do not attempt to manually calculate DST offsets. It's incredibly complex and prone to errors. Be aware of gap and overlap times. Understand the concept of gap times, during the spring forward transition, and overlap times, during the fall back transition. Gap times. If a user enters a time that falls within the gap, example 2:30 a.m. on the day DST starts, you'll need to decide how to handle it. You might shift the time forward to the next valid time, or you might reject the input. Asterisk overlap times asterisk if a user enters a time that falls within the overlap, example 1:30 a.m. on the day DST ends, you'll need to specify which of the two possible times the user intended. The time zone library can often provide methods for resolving this ambiguity. Asterisk test DST transitions asterisk thoroughly test your date and time code around DST transition dates to ensure that it handles these scenarios correctly. 4. Using integers for dates and times, instead of objects. Asterisk the problem asterisk representing dates and times as simple integers, example Unix timestamps, can be problematic. It loses time zone information and makes it difficult to perform calculations or formatting operations without relying on external functions. Asterisk why it happens asterisk integers are simple and can be easily stored and manipulated. However, they lack the rich functionality and time zone awareness provided by dedicated date and time objects. Asterisk example, PHP, incorrect. Asterisk example, PHP, correct. Asterisk key principles asterisk. Asterisk use date and time objects asterisk use the built-in date and time classes in your programming language, example datetime in Python, Java.time in Java, date in JavaScript. These objects provide methods for formatting, parsing, calculating, and handling time zones. Asterisk only use integers for interoperability asterisk if you need to exchange dates and times with systems that only support integers, example some legacy APIs, convert the date and time object to an integer, example Unix timestamp, at the point of interaction. Store and manipulate dates and times as objects within your application. 5. Incorrect date/time arithmetic. Asterisk the problem asterisk performing arithmetic operations on dates and times, example adding days, months, years, without considering calendar irregularities, different lengths of months, leap years, can lead to incorrect results. Treating dates as simple numbers will produce wrong answers. Asterisk why it happens asterisk the calendar is not a simple linear system. Months have varying lengths, and leap years occur every 4 years, with exceptions. Asterisk example, C, incorrect. Asterisk example, C, correct. Asterisk key principles asterisk. Asterisk use dedicated date and time arithmetic functions asterisk use the methods provided by your date and time objects for performing arithmetic operations, example add days, add months, add years, in C, time delta in Python, plus days, plus months, plus years, in Java. These methods handle calendar irregularities automatically. Asterisk consider time zone when adding durations asterisk when adding durations to dates and times, be aware of time zone transitions. Adding 24 hours might not always result in the same clock time the next day if a DST transition occurs during that period. Asterisk test edge cases asterisk test your date and time arithmetic code thoroughly, especially around month ends, year ends, leap years, and DST transition dates. 6. Not validating date and time inputs. Asterisk the problem asterisk accepting invalid date and time inputs, example February 30th, hours greater than 23, invalid time zone names, can lead to data corruption and application errors. Asterisk why it happens asterisk developers sometimes assume that users will always enter valid data, or they don't implement proper input validation. Asterisk example, Ruby, incorrect. Asterisk example, Ruby, correct. Asterisk key principles asterisk. Asterisk validate input data asterisk always validate date and time inputs before using them in your application. Asterisk use data type constraints asterisk when defining data structures, example database schemas, use appropriate data types for storing dates and times, example date, date time, timestamp. These data types often provide built-in validation rules. Asterisk implement custom validation rules asterisk implement custom validation rules to ensure that dates and times conform to specific requirements, example a date must be in the future, a time must be within a certain range. Asterisk provide clear error messages asterisk when validation fails, provide clear and informative error messages to the user, explaining why the input is invalid and how to correct it. Asterisk sanitize inputs asterisk sanitize date and time inputs to prevent potential security vulnerabilities, such as format string injection. 7. Using the wrong epoch, and associated units. Asterisk the problem asterisk different systems use different epochs, the starting point for counting time, and different units, seconds, milliseconds, nanoseconds. Mistaking the epoch or the units can lead to significant errors. Asterisk why it happens asterisk lack of attention to detail. Systems are often built with assumptions without making them explicit. Asterisk common epochs asterisk. Asterisk Unix epoch asterisk January 1st, 1970, midnight UTC, used by many operating systems and programming languages. Asterisk Windows file time asterisk January 1st, 1601, midnight UTC, used by the Windows operating system. Asterisk Java epoch asterisk January 1st, 1970, midnight UTC, milliseconds since epoch. Asterisk example, Python, incorrect. Asterisk example, Python, correct. Asterisk key principles asterisk. Asterisk document epochs and units asterisk clearly document the epoch and units used by each system that handles dates and times in your application. Asterisk convert between epochs and units carefully asterisk when exchanging dates and times between systems with different epochs or units, perform the necessary conversions accurately. Pay close attention to the scaling factors, example 1000 to convert milliseconds to seconds. Asterisk use consistent representation internally asterisk choose a single epoch and set of units for representing dates and times internally within your application, and convert to / from other representations at the boundaries, example when interacting with external systems. Best practices for date and time handling. Asterisk use established libraries asterisk reiterate the importance of using dedicated date and time libraries that handle complexities such as time zones and calendar calculations. Asterisk store everything in UTC asterisk convert all dates and times to UTC before storing them in a database or persistent storage. Asterisk validate user input asterisk ensure that dates and times entered by users are valid and conform to the expected format. Asterisk test thoroughly asterisk test your date and time code extensively, especially around DST transitions and other edge cases. Asterisk understand the requirements asterisk make sure you understand the specific date and time requirements of your application, including the time zones involved and any cultural considerations. Asterisk document everything asterisk document the date and time formats, time zones, and other conventions used in your application. Asterisk stay updated asterisk keep your date and time libraries up to date to ensure that you have the latest time zone information and bug fixes. Conclusion. Date and time handling is a complex and challenging task, but by understanding the common mistakes and following the best practices outlined in this tutorial, you can significantly reduce the risk of errors in your applications. Always prioritize using established libraries, storing data in UTC, and validating user input to ensure data integrity and prevent unexpected behavior. Remember that careful planning, thorough testing, and continuous learning are key to mastering the art of date and time programming.